So in these examples, on the first page, we're going to do a lot of equation solving and symbolic manipulation. And then on the second slide, we're going to do some applications of how you use these powers. And many of these will involve like money and percentage rates or decrease in populations, that kind of stuff. So in the first example, we notice that there's some stuff that has a power, the x to the fifth thing. Eventually we want to get to x equals, that's our goal. So we're going to start working with the equation by, first of all, undoing the -8 with a +8 on either side. And we'll get 0.75 x to the fifth power equals +5. And then the next step would be to get rid of the 0.75 that's being multiplied by the x to the fifth power. So we divide both sides by 0.75. And we get x to the fifth equals, I don't know what that is, doesn't really matter actually.
6.6.
All right, so I'm not going to write it as 6.6, repeat, I'm just going to write it as 5 over 0.75, but thank you very much. And then the big thing is, I need to undo that fifth power. And yesterday we learned that one of the ways was to take like the fifth root of it, but we've been working with what they call rational exponents, which means like a fraction for the exponent. So to undo the fifth power, you could raise it to the 1/5 power. So I raise this thing on the left side to the 1/5 power, but whatever I do to the left side of the equation, I must also do to the right. And as I raise it to the 1/5 power, the way that you type it in your calculator is that x will be equal to whatever we had in those parentheses, which was the 5 over the 0.75, and then you raise it to the 1/5 power. And you'll end up with your answer. And it's going to be some kind of decimal representation. So on my calculator, I have 5 divided by 0.75 and hit enter. And then I raise that to the 1/5 power and hit enter. And so roughly 1.46. So I just write down 1.46. And the more practice we get with these, the more comfortable it becomes, because it's always kind of tough when you first start out. When you're undoing equations, the big thing to remember is you're always kind of working your way from the outside to the inside. So in number 2, I see that on the outside of the parentheses is a 4, so I want to undo that. To undo the 4, since it's being multiplied, the inverse of that would be to divide, so we're going to divide both sides by 4. And we're going to get x to the 5/6 power plus 7 equals whatever 159 divided by 4 is.
39.75.
Thank you. 39.75. And then I need to undo the +7. So to undo the +7, I subtract off 7 from both sides. And now we have x to the 5/6 power equals 32.75. And here we are again with that rational exponent thing, and we want to undo it. So the goal is to get x, and the way you get x is you want to make the exponent a 1. So what you're going to do is you're always going to raise that to the reciprocal power. And the reciprocal of 5/6 is 6/5. So I raise this to the 6/5 power. I do the same to the other side. And the great thing is that our calculator can easily do this for us. So then we get x equals whatever 32.75 to the 6/5 power is.
65.80.
Thank you. 65.80. Number 3, we see that we still have to work our way from the outside to the inside. And on the outside of that parentheses, there's a 200 being multiplied. So to undo that multiplication, we're going to divide both sides of the equation by 200. So as I take and divide both sides by 200, 224 divided by 200 is
1.12.
Thank you. 1.12. And that's equal to parentheses 1 plus x to the 4th raised to the 9th power. Now this is kind of weird because there's a lot of junk inside the parentheses with the power on the outside. But it doesn't stop us from doing what we need to do in order to undo that power. So to get rid of the 9, I'm going to raise both sides to the 1/9 power. And the reason we're doing that again is because the 9 and the 1/9, when you multiply them, you get a 1, so that means pretty much the parentheses will disappear. On the right-hand side, I'm going to get 1 plus x divided by 4. And on the left side, probably some small decimal. 1.0138.
1.013.
0 like this.
Yeah. Sure.
Yes or no?
It would be 0.137.
7? Okay, 7. So that's kind of a weird decimal, but no big deal. Then on the right-hand side, I'm still trying to get that x by itself. So I'm going to subtract off 1 first from both sides. Now we have a really small number on the left. We have 0.0137, and that's equal to x over 4. And since x is being divided by 4, to undo that division by 4, I multiply both sides by 4. So now I multiply both sides by 4. And my answer becomes whatever the 4 times 0.0137 is. So then x is equal to
0.052.
0.052. Thank you. Ones. What you'll notice in number 4 and number 5 is there's no equation. So we're not finding x. We're just simplifying. And whenever you have something raised to a power, what's really going on is you have the 2 things or 3 things or however many things are inside when there's no pluses or minuses, no adding or subtracting, being raised to that power. So another way to look at number 4 is you could write it as negative 27 being raised to the 4/3 power times, and then x to the negative 9 being raised to the 4/3 power. So that could be one of my first steps in order to look at it differently, just to remember what's going on. Something's happening with the number, something's happening with the variable. Now you can take this negative 27 and raise it to the 4/3 power, and you get a number.
Negative 81.
I don't think it's negative.
It's 85.
I think it's 81.
Yeah, it's 81.
So check on your calculator. Remember to put parentheses around the 27, but I'm pretty sure you're going to get an 81, not negative 81. So check it out. You should be able to get 81. And then in the next step, when I multiply these, negative 9 times 4 is negative 36. Negative 36 divided by 3 is negative 12. So what's happening is the number thing over here turns out to be 81, and the variable thing over here turns out to be x to the negative 12. And what you need to know is that in math, when we work with variables, one of the things that you'll be required to do when you're taking your ACT, PSAT, whatever, standardized tests, and in general in mathematics, they like to have variables with positive exponents for some reason. That's kind of the standard language of mathematics. And so what you're going to do, is, what you know from the past, is whenever you see a negative exponent, you can make it positive by changing its position on the fraction bar. So instead of it being right next to the 81, in what we consider to be the numerator, or the top part of a fraction that's we don't even see because it's all over 1, is I can write it as 81 over x to the positive 12. So it was negative 12 when it's on the top of a fraction. Even though we don't see that fraction, we know it's over 1. When I move it to the bottom, the exponent changes sign, and now it's x to the 12. And this is considered to be, over here on the right-hand side, a simplified version of what's going on. And that's kind of the big idea about numbers 4 and 5, is we want to simplify what's going on. Correct. You need to do that to simplify it. It's kind of the whole point about the negative exponent thing. In number 5, I'm going to approach this the same way I did in number 4. I'm going to start out with the two pieces separated. So I'm going to go with 16 to the negative 5/4 power times x to the 28th to the negative 5/4 power. And so 16th to the negative 5/4 power is going to produce a number, some small number I'm sure. .031. Okay, something's wrong. Two different answers. Let's just check it out. 16 to the negative 5/4. 16 to the parentheses negative 5 divided by 4.
That's what I got.
Yeah? Okay, now I want to show you something. This is a crazy decimal. We can always go to get fractions. Math. Enter, enter. 1/32. Math, enter, enter. I would write that down. Math, enter, enter. 1/32. So 0.01325 is 1/32. I'm going to write that down. So this now is 1/32. That 1/32 was representing the 16th to the negative 5/4, so that's what that came from, on the calculator. And then the second part, x to the 28 to the negative 5, 28 divided by 4 is 7, times negative 5 is negative 35. So I have x to the negative 35. And we just talked about in the previous example, knowing that this stuff turned into this stuff, that if we have a negative exponent, we can rewrite that negative exponent as a positive exponent if we just put it on the bottom of a fraction, or in other words, change its position on a fraction bar. So really I have 1/32 times 1/x35, or if I just shove them together so I can just write it as one fraction, 1/32x5, x to the 35. And this would be considered the final simplified answer. And with this $1,000 and number 6 for your birthday, you want to put it in the bank and can only take it out when you